This video will look at some of the access control models, the academic models in particular. We start with the Bell-LaPadula confidentiality model. This model was originally developed for the US Air Force back in about 1973, and it's a state machine reference model. So the idea is it's trying to ensure confidentiality of information by using mandatory access controls, data classification, security clearance. So this is a system that, the state of the system is always in a known secure condition. So what we're trying to do here is to ensure, and this was the aim of the US Air Force, to ensure that information put in their systems was always kept secure. So basically the security rules for a BLP model prevent information from being moved from a level of high security to a level of lower security. Right? So there are two types of access modes. There is the simple security mode and the star or asterisk property. So simple security, which is also known as the read property, prohibits somebody with a lower clearance from reading an object of a higher classification. But if you've got a higher clearance level, you can read an object of a lower classification. So in other words, you can read down. The star property, which is the write property, prohibits a high level subject from sending messages to a lower level object. So in other words, you can't read up, nor can you write down. So this is kind of what it looks like. If you look at this, if we start with the user on the left hand side, the user has read only, so they can't read things at a higher classification level than them. They can read things at their level. They can read things at a lower level. Right? We move to the middle column. Let's call this now top secret. The user in the center has write access, so it can write at that level. It can write up, so it can write information that is at that level, top secret, secret, and it can write up to a top secret level, but it cannot write it down to an unclassified level. If you've then moved to the third column, the one on the right hand side, this is known as the strong star property. And so what this means, you can read and write, but only at your level. You cannot read or write up, and you cannot read or write down. So that is effectively the Bell-LaPadula confidentiality model. Now BEPA is an integrity model similar to BLP, and the whole idea here is to provide you with access controls to ensure that the object or the subject cannot have less integrity as a result of any read or write operations. So in other words, it's ensuring that no information from a subject can be passed on to an object in a higher security level. So this is to prevent contamination of data of a high integrity with data of a lower integrity. So now notice we're talking about data integrity, not necessarily data classification. So this model assigns integrity levels to subjects and objects using two properties: the simple integrity or a read property, or the integrity star, the write property. So if you've got just the simple integrity property, you've got read access to an object if the security level of the subject, that is you, is either lower or equal to the level of the object. So you can read up. The integrity star means that you can have write access to an object only if that security level is equal to or higher than that of the object. So you can't write up and you can't read down. That's effectively the way it works. So here is how it looks. So if we start off at your assigned integrity level in the middle there, 0.01, you can read, but you can read up, but you can't read down. You can write down, but you can't read up. And if you've got the invocation property, then that command, trying to send a command, would threaten integrity, and so it prevents you from doing that. Clark-Wilson is another integrity model built on change control rather than integrity level, and was designed more for the commercial environment rather than a military environment. So here the change control principles that it operates on are: you can't have changes made by an unauthorized subject. An unauthorized change can't be made by an authorised subject, and the purpose is to maintain internal and external consistency. And so this sort of system works quite well in a commercial environment. So these controls are part of this model. So you've got subject authentication and identification, so you know exactly which people are doing what. You've got access to the objects by those people by means of a well-formed transaction, and any execution by a subject can only be done on a restricted set of programs. So the main elements in this particular model is that you have constrained data items, data with protected integrity. You can have an unconstrained data item. So this is data that's not controlled by the integrity model, so you're not validating input or output at all, so anything can happen to it. You can have a integrity verification procedure. This is a procedure that scans the data and confirms its integrity. And then you have a transformation procedure, which is the procedure that only allows changes to a constrained data item. So in other words, you're going through a prescribed process in order to change that CDI, that constrained data item. The Graham-Denning access model is again a different approach to it. It's three parts to it: a set of objects, a set of subjects, and a set of rights. And subjects are composed of two things: a process and a domain. So you have 8 basic rights. You can create an object, create a subject, delete an object or a subject, give read access, grant access, delete access, or transfer access. So they are the rights that you can have with it. The Harrison-Aruso-Ullman model is another model that we can use to allow changes to access rights. But this one starts to look at changes over time. So you're working on an access control matrix, a set of generic rights and a specific set of commands. And so this is something that looks at the change in system and the protective states over time. So it can be a model which occasionally can work for you well. However, the last model we'll look at is the Brewer-Nash, or Chinese wall model, and this is well known in the finance industry because it's designed to prevent a conflict of interest between two parties. So in the Brewer-Nash model, you as a user can select one of two conflicting sets of data, after which you can no longer access the other set. So it's designed to prevent this conflict of interest. So you as the user there, the consultant, the financial advisor, whatever, select an organization or a set of data that you're going to work with. The Chinese wall comes into play and you can no longer access data from the other side, and that prevents any conflicts of interest. So they are the basic academic models, some of which you will use, the Bell, the Padula and the Beeper, the Brewer and Nash model you will certainly use. Others may be useful for you from time to time.